Hello, good morning. My name is Elias Torres, and I want to talk to you today about continuous delivery, 500 deployments a day. But first of all, I want to say thank you that you're here. I didn't think there were going to be that many people here. 10 a.m. The previous talk was much lighter, understandably so. Last night, how many of you guys went out last night? And it's, I praise you for being here. It's rough. Little story, last night I told a friend I was arriving in Vegas. This is my first time actually as an adult here. And he set up some VIP red carpet service. And somebody was going to take us, my friends and I, to a club. And the guy says, "What time would you like me to pick you up?" And I said, 9 p.m. Right? It's a joke. And he said, the club doesn't even open until 10:30. So I was like, I'm out of place here, but this is the right place. We're going to talk about deployments. I'm really excited. I want to make sure that everyone here is at the right talk. I know I didn't put in my abstract Docker, because if not, this would be just completely packed and people would be going away. But I will talk about Docker anyway, so make sure you guys enjoy that. I want to make sure that you're here because you're a developer, that you're building applications that run as a service, that you care about deployment, right? Or you're an ops engineer, right? And meaning that you want to help the operations and the flow of the code out to the customer to happen continually all the time, right? I hope I piqued your interest with that title of 500 deploys a day, and I'm going to tell you a lot about it, of how we do it at HubSpot, right? My goal, right, of this talk is that you guys really enjoy releasing software. Raise your hand if you are deploying snowflakes back at your company. You know what I mean by snowflakes? It's like every single deployment is different, right? Every single service requires different software, a different machine, different process, right? So I didn't see hands. Are you guys having a tough time deploying at work? Is it easy? Are you having fun when you're like, oh yes, let's release the new version of the software, right? And you're like, yes, let's do it. No, right? And most people are like, how do we roll back? And then we have this rollback procedure, but that one never works either. It's scary, right? And I want to tell you how we made that very, very exciting at HubSpot. But first, let's level set a little bit. This is Amazon conference, but I want to make sure that we understand what we're doing here. What do I mean by a modern service in this cloud era, right? Because I'm not talking about some system that runs on an AS400. I'm sorry if you have to run one of those at your company. I'm just talking about the things that how we build software nowadays, right? Microservices, right? Buzzwords. I took this from 12factor.net. It's a manifesto that was written from the guys at Heroku. That I saw this about 2 years ago, and it really transformed how I thought about deployment. And I just want to remind us of that, right? One is that we want to use declarative formats, right, for setting up automation. We don't want to be using code every time to try to establish how a service runs and operates and it's configured in a system, right? We want something that someone can just go edit very quickly on your GitHub repo, and now you change what you're deploying. Example of this is like a YAML configuration file that you can have in your repo, and you want to make a change to it. Just go edit that right there and hit deploy again, and it should just work automatically. You want to have a clean contract. This is something that is happening. We're in a great time in the evolution of deployment and back-end software, because we keep separating, right, our requirements, our dependencies from the host, from the container of the services. And by having a clean contract, it's like you require very little from the OS in terms of your application needing to run. Example of that is that you need a file system for some temporary state. You need networking. But that's about it, right? And a kernel and a processor. But you don't want to be like, oh, I require this binary and this runtime and this library and this file in this specific location. that kind of stuff, right? You want to minimize, right? You want to have a very clean contract because you want your system to be portable. You want your system to go and be able to move from different environments. A service that I'm talking about, it has to be something that is for deployment on modern cloud platforms, right? It's not just, back to the AS400 or AIX or something like that, where you need a mainframe or something that you can just grab a Linux box and you can deploy your software, right? And something that you can easily replicate, so you can create multiple environments, right? You can have a staging, QA environment, and you can have a production environment, and you don't want the systems to be different. You don't want any headaches. You don't want to be like, oh, that bug is in the staging server, right? It's like, no. It's like, you want them to be the same. You want to be able to tear them down, bring it back up. No problem. And ultimately, you want to scale up, meaning you want to be able to grow with the needs of your service, of your customer base, without having to be making changes to the architecture, without having to be having to improve your deployment tools. You don't want every time you need to grow or you need to deploy another service. This is not just only scaling up the number of instances of your service, but how many services you manage, right? You don't want to be in that mode of, oh, we need to deploy our third service and our infrastructure doesn't support that. It only supports deploying one system, right? So you want to have a deployment strategy that supports you scaling up, right, with the business needs. If we try to make this a lot more practical, basically what we learned is that a service, a microservice, is just an IP address and a port to us. That's really all we care about. And we keep evolving that and learning from some of the most advanced players like Google, Twitter, Airbnb, of Netflix. They have their own track, I heard. And you learn that every service is just an IP address and a port. When I first got to HubSpot, we had this DNS entry to this IP, hard-coded to this specific port, and Tomcat was installed on a specific path, and we had to drop a WAR file in the right place. And I'm gonna tell you, it was a nightmare, right? It's like, guess what? If we wanted to run a second web service on that machine, that was just disastrous, right? And it's like, start hacking our Fabric script to deploy and trying to add a second port, and it's just horrible. So if we take 12factor.net, it's like everything's an IP address and a port, and everything gets configured through environment variables, right? You create your system that when it starts listening, it grabs the port that it's going to listen on through an environment variable. And this is kind of another example of what a clean contract with the operating system means, right? This is the way you communicate. It's not like through, you can always take port 9090 on your machine. No, it doesn't work that way, right? So you tell it a few key configuration properties that you need, and then the service can respect that, like where to log its information, temporary data, and that kind of stuff, and respect that contract. Obviously, it's probably a bad idea to put your key in secret there, right? There's better ways to do that now with roles, but forgive me. And ultimately, I know there's a lot of talk about containers, but there's many different ways you can do containers, right? For us at HubSpot, we just learn to just package all of our applications into a single file, a single tar, and have it bring all of its dependencies with it. Where there is a Node.js project, where there is a Go-based project, we use a lot of Java at HubSpot for our backend. And so our entire service, right, our microservice is just bundled in a single jar. So running that is extremely simple. This is kind of what I mean, right, by that clean contract. And that there. So here's an overview. When people were giving me feedback about my talk, they said I didn't have any diagrams. So I grabbed a whole bunch of the icons that they gave us in the template, and I just threw them there. I don't know what they mean, but let's move on. So let me tell a little bit about HubSpot and kind of give you real life examples of how we've done this, right? And I would like to inspire you because I was walking down the strip, and there was a guy from a company, and they're talking about deployment, and I'm like, oh, I'm giving a talk on deployment. And we just started talking about it, and he was just like, he was frustrated. You know, I could tell that he was trying to, how do they bring change into their company? How do they move to a mode where everyone can go really, really fast, right? And I'm going to tell you here that this is possible. I'm going to tell you a few things. First, it's possible. Second, you got to start somewhere. And third, you got to know where you're going. So by the end of the talk, I want to leave you in a good place. Like, okay, that's where I want to go. That's what I want to take my company to. And you can go back home and start doing it, right? So this is a little bit of story about HubSpot. HubSpot is a marketing company in Cambridge, Massachusetts. I don't know if anybody has heard of it. Heard of HubSpot? A couple. Not a lot of marketers here in the audience, I'm sure. But for those of you that don't know, we're software as a service. We're a platform. And the CEO came to me and it's like, he acquired my company, and that's how I ended up there. And he had this crazy vision, which is like, I want to provide every possible software that a marketer needs to do their job. And that's the last time I listened to that kind of advice or offer. It's like, because HubSpot is insanely big for its size, for its engineering department. But that's what's been really impressive, that we were able to do this. And I attribute a lot of that success to our deployment strategy and our culture for releasing software. But you know, it's like most companies get to focus on one thing, and focus is good. But when you have to implement all of those products together and compete with all those companies at the same time, it makes it really, really challenging. So you want to remove as much friction as possible. So HubSpot lets you do everything that MailChimp lets you do. We can send mail, transactional, marketing, stats, click tracking, open tracking, all that stuff. You know, we send like millions of messages a day, and it's just crazy. A lot of growth, a lot of scale. We do the equivalent of Google Analytics with a lot more detail, all the way to the individual level. We have the equivalent of WordPress. We have our own content management system. It's called Content Optimization System. We do social media and monitoring. We do, now we just released a CRM, and landing pages, and so much more. So we had to build a lot of these services with a very small team that recently has gotten up to like about 100 engineers. So let's go back now to the title of the talk, right? 500 deploys a day. Raise your hand if you think this is bullshit, or like this guy's nonsense. He's tweaking the numbers, right? So, yeah, good. Not everyone's just buying everything I'm saying. So what does it mean, right? So we have, actually, let me switch the order. I'm gonna go rogue. This is about 2 months old. But for a small company, and there's just no Google, there's just no Facebook, we have completely embraced the microservices route. And we have, 2 months ago, 843 deployable artifacts, right? So this is a lot of software to manage and to deploy. I don't know, it's probably like 900 plus now, right? It's like, and 219 of those are web services. We have workers, we have scheduled jobs, and we have on-demand, one-off jobs. And what we kind of did, right, is that we evolved our deployment strategy to create this kind of primitives. And we have these very basic types of, you want to deploy a long-running service that is stateless, that all it does is connects to databases or HBase or Memcache or other things. So anytime you wanted to deploy that, in whatever language, although we mostly do Java, we had a pattern for deploying that. So when the CEO said, I want you to build the CRM system, we said, okay, let's grab 2 of our best engineers and start building. And they didn't have to change one thing, in our deployment system. All they had to do is focus and start building their product. We also have workers, right? So this is long-running processes that don't need load balancing. I think that's the big difference, right, between the web service and the workers, is that the web services need routing in order for the request to be taken directly from the web consumer. The queues are just processing stuff out of an HBase-based queue that we built at HubSpot. We have scheduled jobs, right? A lot of these Hadoop jobs that are running. And then some on-demand jobs like a migration or something like that. We want to migrate a table on HBase. You want to run something off whenever it's needed. So this is kind of our suite of services that are managed by our deployment system at HubSpot. And this is the reason why we have 500 deploys a day, right? It's that every engineer at HubSpot is deploying on average 2 to 3 times a day to production. Deploying at HubSpot is a non-event. We don't think about it, right? It's like, all we're thinking about, how do I get this change that I just committed directly to our customer? It's like, somehow, this other team needs this extra property on this endpoint and this JSON endpoint. How do I get that to them? I need to put it out there, right? And so that's how we get this like constant flow of deploys throughout the company that is really hard to control. But I think that it happens in a really good way for us because we can work in parallel. That's one of the biggest things that I've learned is that when you have to build a big platform like HubSpot, you can't be stuck in centralizing everything, right? If we're parallelizing our systems, we're using distributed environments and Amazon, why not do that with our coding practices? So honestly speaking, it takes us about 10 to 25 minutes to really go from commit to production. Let's say that I commit some code, I push it, Jenkins waits for the webhook, builds that, right, and packages that jar and the entire repo, right, as a build pack, and it uploads it to S3. Runs the tests, doing that kind of stuff, unit tests, things that you can run in Jenkins. And then from there, we can say deploy. So we have a web interface and we have a command line interface that all it's doing is kicking off that deployment on our system in a slide coming up. And we'll ship that to staging, to our staging environment. And there, we do some testing, and let's say that takes 5 to 10 minutes, the whole process. Like, the most it takes us to the longest build in our system, because we're using microservices, it's like 5 to 6 minutes on Jenkins. And that we really hate is still too slow. I want that to be faster. But that's Jenkins' fault, and Maven, and Java, and a lot of other things. But we're OK. And so once you deploy to staging, that's the only requirement, is that you can't really deploy to production until you first deploy that release on the staging environment. And then after that, you go ahead and you say deploy to production. Deploy service name production. And 99% of these releases don't need any coordination from any other team. At HubSpot, there's about 100 engineers, and they all split amongst themselves, right? All these deployable units. So everyone owns 2 to 3 different services that they're fully responsible for. This is something that I actually gave this talk at a couple of places in Boston before coming here, and people still come to me and they say, trying to give me the advantages of why building a monolithic system is good. And so I just want to reiterate, right, that it can be done. It does bring its complexities, but it has a lot of advantages. Just like when we want to train our engineers to say, write a very small class file, right? It's like, something, single responsibility principle. When you want to write a class that does just one thing, right? The same thing we believe with our services. Try to make the services just do one thing and do it well. So in order to scale, you hire a second person into the team. You can say, well, now you own this service. And it's very easy to grok, right? You can just look at it and say, OK, it just has 2 endpoints. Really easy to understand. And you can take advantage of that. So this is our examples, like how every little thing at HubSpot is a service. Our authentication system, our login page, blogging, the navigation bar at HubSpot, it's a service. So every app calls the navigation service to render that. And you can stitch together all these different applications running on different systems, right, on different services, code bases. But it makes it look like one system, right, to the customer. And so it has been really, really useful to us. And what about the benefits, right? I think that To me, it's about developer happiness, really. If your team is not happy, you're not going to have a great product. You're not going to have a great culture. You're going to have a lot of churn. People are going to be unhappy, and they're going to do their worst job, right? And so what we've done is that we created very small teams. Just like we have microservices at HubSpot, teams are max 3 people, 3 engineers. And they're responsible for everything that has to do with that product and whatever services that requires, right? So a team of 3 people can own a front-end app and 2 or 3 different back-end web services, right? Or cron jobs or queues. And they're responsible for the whole operation for deployment. For the development, the design, development, deployment, operations support, they get the phone calls. They're the ones who get called if something goes down. So what we did is at HubSpot, we wanted to invest and say, we wanted everyone to have to do the least amount of work possible to support their services, right? And mostly focus on writing code. I mean, that's what engineers want to do. And we couldn't afford to have a very complex, have a QA and ops team and have a development team and have them bickering and fighting about whose fault it is that the system went down. And so this is really central to HubSpot culture and the ability for us to hire, to grow, and to retain an amazing team. But because we invested in this. And that's something that is very, very hard to justify to the rest of the business. So my answer to that, you guys always have this problem where you're like asking the rest of the company, can we refactor this service? Could we build some infrastructure? Anybody has problems trying to get time for that? So I got the answer. Don't ask for permission. Just do it. So like, yeah, we're working on that feature. And then like, do it. But we have a big responsibility though. I think that the counterpart of that is that when we go dark and we disappear for like 3 to 6 months because we're building infrastructure, then we lose their trust. So what we did at HubSpot is that we never told anybody we were working on infrastructure to build all this stuff that I'm showing you today. But we never went dark. We were always trying to balance both of them, right? It's like we were deploying, making changes, and building this infrastructure. But it paid off, right? And the good news today is that you can use it. We're giving it away. It's open source, and you can try it today. But sorry, I'm getting ahead of myself. The way that we did it at HubSpot is that we used to do things that Apache Mesos. I was two and a half years ago, I met Ben Hyman at Twitter through some common colleagues. And we were evolving our platform to do this kind of deployment, but we were missing one big part of it. We were missing the part that will actually manage that process in our machines. Remember, we used to have like a single machine per service. And it was highly inefficient. HubSpot, we had like 2,000 servers, VM instances running machine, like a staging. Every one of those deployable units in staging had to have at least one machine to run it, and it was just a nightmare. It's like, and now imagine how many we needed in production. And so we needed to be more efficient. We needed to automate that, and we needed to have a way that if a service died, or a slave died, a VM disappeared, we wanted that to automatically start. And so we were still doing a lot of those things by hand. And when I met Ben and he told me this is how Twitter runs it, I said, that's what I want, right? I want to have what this big companies have in our small company. I want to have the same benefits, and why not? It's software, it's free, right? And so it was really exciting for me, and we started, again, those grassroots efforts, integrating this and evolving our platform to use this. If you guys don't know what Mesos is, but I'm sure now you've been hearing a lot about it, it's Mesos is a framework, it's a platform that lets you run your applications across your entire data center or cluster or cloud account, like if it was just processes on a single machine, right? It's like, you launch on your Mac, PowerPoint, Keynote, or whatever. It's like, okay, there's another process, there's another process. So that's what it is like with Mesos for us. It's like every one of our microservices is just a process. And what it gives us is the IP address and a port. This is the simplest way to explain Mesos, right? And what happens is that if one of those machines dies, it just tells me, hey, one of those instances died, and here's the new IP address and a port. It's really that simple, right? And so it allowed us to do this both on the cloud and in our own data center, right? Where you can, take that same technology that allows you to manage multiple services in a single machine or 2 machines, 3 machines, and do it wherever you go. So there's really no excuse, right, that, oh, I have to be all in the cloud, or I have to wait for ECS to be deployed, the Elastic Container Service thing. You can just do it anywhere. You can take Apache Mesos, and it will work in any of the different scenarios. Like, I don't know what scenario it wouldn't work in, but the first thing that we were able to do is, like, for example, in staging, we used to have like 200 to 300 servers to manage all those instances. And guess what? When you're managing those instances, you start saying, oh, should I use a small, medium, large? What should I use for this machine? Instead, we grabbed those 200, 300 machines, and we just ran staging in like 18 of the beefiest servers you can run in Amazon. And Mesos is just scheduling our services in there, and we no longer had to worry about it. It's like developers never, again, at HubSpot, go and launch a machine on Amazon anymore. Right? It's like there's a couple of people that have access to growing the Mesos, the Mesos cluster, and that's it. They just simply say, I want 2 instances, 3 instances. This is a whole bunch of, just don't worry about it. It's just, Mesos just runs your applications in your cluster, right, like a single computer. Microservices, microservices, microservices. I already told you about this. We use this thing called Dropwizard that, for us, simplify how we use Java. It just beautifully packages your service in the container. It puts Jetty, it puts everything it needs to in one jar, and you can build a web service that receives and responds JSON very, very quickly. Dropwizard is kind of like a pattern that we were able to learn to do this, right, to have this jar. And then the other component of it that, Mesos, when we first started, was kind of missing was the complete suite of tools necessary to manage all those primitives that I told you earlier, right? We have web services, we have cron jobs, we have queues. And so Singularity is an open source project that HubSpot has on GitHub that you can download, and that's what I'm going to run the demo from, that has a whole bunch of features, right? For you to actually do this in your company, to deploy software, right? To enable, to really like power up Mesos to do most of what you're going to need to run a modern cloud service, right? It has, I'll just go straight into the demo. But in a way, it's like kind of like autoscale for microservice loving teams, right? It's like, it lets you, okay, let me build another service and hit deploy in Singularity and Mesos, and off you go. I'm gonna now jump into a demo and kind of give you a little bit of what's happening. Every demo probably uses WordPress and Nginx and MySQL. So I'm gonna do the same, but I'm gonna show you how we can deploy that using Singularity. Both it has a user interface, and it also has a complete RESTful interface to deploy. And the good news is it's gonna use Docker as a demo. I'm sure you guys never seen that, starting a Docker container that starts up WordPress, right? But you're gonna see it again today. So I'm switching to the demo, another one of those template slides. And what I did is I went to, I'm using a Mac, and the first thing I did is did brew cask install VirtualBox. VirtualBox is a open source VM. You can run a Linux VM inside of your Mac. I installed Vagrant. It's what we use to package a demo of Singularity. So it's very easy for you to try out. I cloned the Singularity repo from GitHub, and I installed some of the Vagrant plugins, and I saved Vagrant up. Okay? So this is the state of my machine right now. That's what I've done, and now I'm going to switch over to my other machine. And now, you're looking at, let me see here. Okay, that's better. Can you guys read that? It's too small. Okay. And so this is the user interface that now that any developer at HubSpot can see to manage their services, their deployment, and have quick access to like log files or be able to scale up, scale down, and manage how many tasks or failures are happening with their boxes. And so the first thing I'm going to do is I'm going to create a new request, and I'm going to so I'm gonna create a request, which is like it's a new web service, right, or a new service that I'm running, and I want to run MySQL. Okay, so that's the first thing I create. Then the next thing I do is I'm going to create a WordPress service that is load balanced, right? This is the other type of service, right, where we're going to have requests being directed to it. And I'm going to hit save. So right now, nothing is running. All I did is I just created a request to have tasks executed. So the thing I can do here is I can deploy an actual MySQL instance. And so I can enter a few commands in here, and that would be deploy. But I also want to show you the RESTful version of it, because it's very important to integrate with your existing platform. You guys want to know, like, how am I going to call that API to the deployment? How do I get that one click, one button push, one API call deployment feature that I'm looking for, right? So I'm going to show you how we do that. So I'll switch to the terminal. And in here is a JSON file that it's going to run a process. In this case, I'm going to run a Docker process, a Docker container in Singularity, right? It's just going to launch that, and it's going to create a database. Normally for us, an executor in Singularity will give it through an environment variable the URL to the S3 bucket, that contains our deployment, and it just fetches it, untars it, and executes the command line that we specified in our YAML file. But in this case, I'm just going to do that, and so I just did a HTTP request. I'm using HTTP PI, but it's the same thing as curl. And if we switch over to the so right now it's the Docker container. So I was able to see from this web interface quickly. I didn't have to SSH into the machine, look at the process or anything. Okay, MySQL is running. Then the next thing I want to do is deploy WordPress, right? And same thing. The thing that is different here is that it has a service-based path to route HTTP requests, right? So I'm going to hit save. And I'm going to hit deploy. And so if I go to the request for WordPress, there's one running. And the Docker container already ran, and it should be listening. So the way that we look at it is I'm going to go to Vagrant, and there is the WordPress container talking to the MySQL database, and it's up and running. So I guess okay, so I just installed WordPress, right? So, thanks. So now I'm going to SSH into the Vagrant machine, and I'm going to show you the Docker process. And those are the two Docker processes, right? So let me cause some chaos and kill the WordPress Docker container, right? Right? So if I do PS, guess what? There's another one running, right? So that's what Mesos does. It's like it runs a process, You told it, I want you to run this process, and this is the spec, and I want you to keep it running forever. Anything happens, you go launch it somewhere else. And he has all these cool down properties and back off and everything, and alerts and doing all that kind of stuff. But that's what it does, right? It's like, you don't have to worry. You know how many PagerDuties did that save us at HubSpot? Lots. That's where developer happiness comes in, right? Got a little bit of time left, and so let me show you something else, right? Look at that, right? Remember I told you that every service should be an IP address and a port? Look at that. That's running on 31.932. That's where WordPress is running. Let's kill it again, just for it's fun killing stuff here. Oh, now it's running on 31.843, right? And so Singularity comes with this service called Baragon, another microservice, right? That what it does, it keeps track of what every time Mesos sends an alert and says, guess what? We just relaunched that. We just relocated your process because it died for some reason. And now we have a new IP address and a new port. And so we need to route traffic to the services. And the way I'm doing it in this case, Baragon supports both HA proxy and Nginx, which is pretty common, what normally we would do to route traffic to that. And so I'm going to go here, and I'm going to cat. So this is the upstream configuration in Nginx, where it tells it port 80 routed to this specific port for where WordPress is running. And so every time that, let's do it again. We kill it, and it comes back again. By the way, I never practiced this on my demo, so I'm going rogue. Here, it changes the configuration to the new port. It's instant, right? It's like very little downtime. It will just, without any traffic disruption, it will tell Nginx, this is the new port, this is the new upstream, start sending new requests to it. And so now we can go here and we say, right, so my host, my thing running on port 80 just continues to run. And that's the peace of mind that Mesos gives you. And you don't have to be bound to ECS or a specific area. You can run this wherever you want. And then let's do another fun thing that Singularity and Mesos can do is that I'm going to scale it up, right? So I'm going to change the request for WordPress to go from 1 machine to 2 machines. I just want to say, how many instances. Remember, I wanted to have that clean contract where I just want to change something. Declarative, clean contract, I don't know, they all sound the same thing. But so I'm going to do this, I'm going to save it, and I'm going to tell Singularity that I want to run 2 instances of that. So right now, WordPress is only running 1 instance. Right? So when I do this HTTP request, or I can actually do it from the browser too, right? I can do scale, and I can change that, right? That number up and down. So now, guess what? There's 2 requests. There's 2 services. And so all you need to do really to scale up your business is keep adding more Mesos slave to your cluster, and you have a lot more CPUs to keep running your software, right? Your services. And if I go here, now there's 2 entries in my upstream configuration in Nginx, and I didn't have to do a thing. So you guys are noticing what I'm doing, right? There's open source software that lets you run all of your microservices with the ease of just making an HTTP call. And you tell it, just run this service for me. Highly available, tolerant, failure, detecting, blah, 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 and all these buzzwords, very, very easily, right? I think, let me switch to the other computer here, this ThinkPad. And, I was struggling trying to come up with some formula. I wanted to create some theorem or something, but this is my best try. It doesn't even have good grammar there, but Mesos requires resources, right? It uses Zookeeper, it needs slaves, it needs master, so you can have high availability. So it takes minimum like 5-7 machines to run it in production. So if you're a small startup that only has one service, you don't need to use it right away. I just left HubSpot to start another company, and I only have 2 web microservices so far. So not using Singularity yet, but I will once I start going into production. But I think if you have more than 10 services, raise your hand if there's more than 10 services in your company. Let's see. Raise your hand if you only have 1. Oh, so I guess there's a whole bunch of people that has less, between 1 and 10. And so I just tell you, you can't afford to be running and deploying software the old way. There's just so much advancement in deployment and evolution of containers, moving from virtual machines to application-based partitioning, that it's just nonsense. We've got to just take advantage of this. And you don't have to build it yourself. There's a lot of open source like Singularity and Mesos out there for you to use it. So go home, stop deploying services manually. Thank you very much for your attention. I'm open to questions now.